This video is sponsored by Kallipr.
Australia, home to killer spiders, massive fruit, and trams?
I got that wow. Who wants some hands up right now? We got that, turn it up loud.
Melbourne has the biggest tram network in the world, with almost 500 trams running 24/7. These things are everywhere. Look, here's one here. They're everywhere, and they don't stop. Well, very easily anyway. And look at them, unreal. Dominating the road. But despite being a Melburnian and being around trams for so long, I realised that I don't know a lot about them. And I wondered, why are they so hard to stop? And what other things does a network of this size have to deal with?
Sand.
Wait, what? Let me catch you up real quick. This is Chris. He's from CLIIIICK IT, the operator of Yarra Trams. Now, he's invited me along to this new IoT trial that they're running to help reduce maintenance on their network. Yeah, I got friends in high places, so let's just rewind a bit there.
So Chris, what is the biggest maintenance issue you've got with trams?
Particularly this time of year, we're talking about sand.
Sand.
Yeah.
Sand.
Yeah.
What do you...
Sand.
What do you even use sand for with trams?
So we actually use up to 250 tonnes a month of
250 tonnes a month.
Yeah, and it assists trams in braking out on the network.
At this point, I thought Chris was pulling my leg. But then he showed me where the trams poop out the sand to help not only with braking, but also with slippage on the track. Chris explained to me that this system is largely automatic and will activate when the tram detects slip. And it can also be deployed manually by the driver, which sometimes leaves these huge pyramid sand poops. Okay, now I understand why the trams use sand, but it had me wondering, why is this such a big issue for them?
You'll make this rather snappy, won't you?
This here is a point, and it's where the mechanism creates a change in direction for the tram. But if you get any silt or grit inside of this thing, it can stop working or, at worst, derail the tram.
You see, these points are traditionally checked manually and can cause a lot of downtime for the network. And this is where Kallipr's remote monitoring unit can help. But how does it work, and what is it trying to detect anyway?
So this setup here is super simple. You've got the Captis Pulse Lite, which has two inputs. So you've got the first warning shot on this reed switch, and then the last one, when it's overflowing, is this top one here.
You see, when it rains, these points fill up with water and eventually drain away. But if they're full of sand and debris, they'll fill up much quicker and then drain away much slower. And that is what they're trying to detect. So while sand is clearly enemy number one, there is another major issue that all rail networks face.
Extreme heat, extreme heat, extreme heat.
Got me headed to the left, headed to the right, headed back and forth, but baby, it's alright.
So a problem we have on hot days is that rail can expand and grow, and for us as maintainers, it's hard for us to know the locations we need to go to first. So what these sensors will do is give us the information for how hot things are in each location and tell us where to go to first.
What Chris is trying to say is that they're installing two units on either side of the track. The first is untouched premium ballast track. This is the control, and the other will be coated in a heat-resistant paint, which will be compared against the control to see its effectiveness. But I bet you're wondering, how does this sensor work? So over here we're measuring the ambient temperature in the air, but here is where the magic comes in. This is a neodymium magnet that has 15 kilos of pull force, and it gets put on the rail just like that. Oh my God, that's unbelievable. Wow.
As we headed back to the depot with Chris, I was curious to find out why this innovation was so important to CLIIIICK IT.
Yeah, we've always taken the approach of not just maintaining, but also trying to innovate and enhance the way that we do our work on the network. This is a good example of that, where we have seen a problem and tried to find a way to make the maintenance of it better.
I've always been amazed at the way that infrastructure works and how technology can help us better understand it. But as my day draws to a close, I felt a new connection with these rhinos of the rail and reflected on the true reason that these iconic trams have lasted so long. innovators like Chris, the maintenance crews, and of course, the drivers, who add a human touch that's the true power behind Melbourne's amazing tram network.
Wait, what gives? Did the trial work? So, it's been a couple of months since the trial began, and the results are looking pretty promising. Chris told me that there's been several points already attended and immediately cleaned as a result of higher level alarms. Pretty cool, I reckon. As for the rail temperature, even coming into the colder months, Keolis Downer has seen a significant difference in the ambient air temperature compared to the rail temperature. So, as you can imagine, this is going to be critical data for them coming into the hotter months. So, if you're looking for an IoT solution for your assets, head on over to Kallipr.com and see what they've got to offer. And hey, if you're not convinced, check out this video on how Kallipr is helping save millions of litres of water every year.
And it's here where I'm searching for one of the most elusive of water creatures there is, the leak. Recently reported that they received over 155,000 megalitres of water for this annual year.